Hi, hi, I'm Sunny, and this is my submission for Valura AI Team Lead assignment. And to build this assignment, this wealth management AI span, my primary goals um, was to strict latency targets and also keeping LLMs cost near zero where possible. And now let me walk you through the entire architecture and the core. So first of all, I would like to walk you through to the safety guard. So safety guard, I haven't involved LLM calls here. So if we can use the regex Python regex just to filter out the topics, right? So like yeah, so I built a pure Python regex engine in guard.py. So it explicitly looks for harmful X and words combined with prohibited topics uh, like uh, like consider yeah. So like insider trading or market manipulation, and this allows us to instantly block malicious queries with 100% recall while still allowing educational queries, right? And to pass through simulation, it executes in less than 1 milliseconds. So it totally rejects based. There's no Python. There's no LLM involved. Just Python, as mentioned in assignment. Here also I've run the test cases. You can see I've already run this, and it has passed all the test cases, 7 test cases. Now let me walk you through. As we have less time, then I can walk you through the main core architecture, which is the graph, and it involves the each node, like the intent classifier node. So first of all, so the LLMs without you actually I've used LangGraph. So just yeah. So for this is the orchestrator. So the instead of simple if else script, I build the pipeline using LangGraph. Here is why this is a non-obvious but critical decision. The assignment requires an ecosystem of a specialist agent. With LangGraph, the state of the conversation cleanly passes from node to node. Like we have a node here. You can see here, like we have classifier node, portfolio health node, and a agent agent node, right? So in workflow in the line graph you can create a multi-agent system easily, and it has also a very great capability, like it has a built-in state management, so we don't have to use redis or any memory just to store the context, right? And yeah, so the what happens is like the with line graph, the state of the conversion clearly passes from the node to node. If the team wants to add 10 new node later, then then we don't have to write much code. We don't have to rewrite the pipeline again. We can simply add those nodes and update the conditional routing dictionary, right? The intent classifier node focus the LLM to output the strict JSON schema, which guarantees we get the intent entities target agent perfectly formatted every time. And then let's see the portfolio health. So there is a two things here. One is the LLMs that analyze the portfolios and gives their observations and justification why that LLM has given analysis. Yeah, so there's two things involved. One is the based on the input given, the query, the input given, the portfolio data. So I'm using Y Finance to retrieve that, and using a deterministic way to calculate mathematically all the informations, and those calculated information further I pass to the LLM, so that those calculations can be utilized by LLMs to take decision and analyze the portfolio of the user, right? And it gives a very data driven decision, right? So like here you can see this is the portfolio details of the user, and this is the computer matrix. So for the computing matrix there is no LLM involved, just a Python script. Here you can see, right? And yeah, so that's, and also you can see one test case passes here, and yeah. So meanwhile, I can also walk you through the some. endpoint. Yeah, and this is the main.py code, which is the where the main fast API is here. So which is hosted on the 8,000 ports. Yeah. And let me walk you through the postmans that you can test. So like I had one this user query and this user demo one and this is the position one. Let me test it. And what do we get? Okay, sorry. Actually, my yeah. So I have to run first. We have to run the you have to run the fast API first. My fast API was not running. Now it should work. This is the fast API. And yeah, sorry, I forgot this. This is the schema. So based on the assignment, I had a schema for the entities, for the subverdict and the classification output. Similarly, for the query request, like we have user query ID, user context. Now the server is started, and I can hit this. Now it's connected, and it will give us the analysis of this portfolio. You can see the intent extracted the portfolio health and the target is portfolio health, and yeah, and now you can see the concentration risk here. You can see these are the consent. So the 82.6% concentration risk, top 3% is 100%, and also based on this information it decides to flag it high because the concentration is too high here. Similarly, the benchmark is this. These are the benchmark, and these are the observations. The severity and text is justifications. You can see here, and also yeah, and this is the classifier, and this is the health agent classifier. It classifying the intent, target, extracting the entities, and also the giving the safety verdict. Right? And still we have time. So, yeah. So as you can see, everything passes to ensure this runs in our CI/CD pipeline without needing an OpenAI API key. I utilized unit test mock. So actually, I have mocked some test cases here so that in production we don't need any open API key. You can see here like you can see the mock. I have used the mock. So as mentioned in assignment, I have used the mock. I mocked the LLMs without using the open API key, right? And let me run few more examples. Yeah, so I think I'm done with the assignment, and yeah. And I achieved this using fast API, and the response is streaming, and I achieved this through a fast API and SSE started to yield server sent event async. And then thanks for the reviewing the code. I would love to chat more about in the next round. Thank you. Thank you.